Welcome to Ask and Learn.
We have a guy using a hand truck to try to move some package or crate up a step. And we can kind of generalize this schematically is that we have our crate here, and then it has some weight. And then there's a reaction here from the wheel on the step. So the step would be kind of here. And because we're concerned about when he starts to lift it off the ground or it starts to lose contact. There's no force in the vertical direction here because at this point it is lifted off the bottom surface, so the tire is no longer contacting the ground here. So in this state, we have just one component of force at this point, and I'm going to use this as my origin here. You can think of it as the center of the tire, if you want. Then we have two components of force here, and this is where the person is applying the load to try to lift this thing up the step. And then we can, basically find where this load, where this force is acting. I just broke it up into a couple different vectors. One vector from kind of the center of the tire to the frame of the hand truck, and then another vector up the hand truck to where he's actually applying the load here. And it doesn't matter, anywhere along this plane is fine, so we know this distance here. So that's what this is. Okay, so we go in a little bit, and then in a little bit, then to, well, wait a minute, in a little bit, then up to here. So, and then we have the weight acting, and then again the position of the weight. We can just use the geometry that's given, and again broke it into pieces, one to here and one to here, just kind of to illustrate it a little more that we can just break it into kind of simple pieces in two vectors. And once we know the forces and the positions of those forces, we can sum forces and moments and set them to 0, and we'll get 3 equations. And we have 3 unknowns because we know the angle of this hand truck is 60 degrees here. So we plug everything in, and we get that the horizontal load at the tire is 442 newtons. The person is pulling equal and opposite that amount, so it is in the negative direction, so pulling it. And then in the vertical direction is lifting it, and that's in the 491 newtons. So we have no reaction both the wheels and the magnitude and direction of the minimum force required to grip. Okay, so then obviously then we can figure out the magnitude of this, and that is 660 newtons, and it has an angle of 132 newtons with the positive x-axis. So it's it's over here somewhere. Obviously it has a negative x component. So he's pulling up. It's close to 45 degrees past 90, so pulling up like about this angle here. Obviously these things are pretty close to one another. So that's what the minimum force is needed to lift this hand truck up the step.